Hello, my name's Liam Bastick. I'm from Some Product, and today I'm going to take a deep dive, as they call it, a more detailed look at dynamic arrays. Now, there is a shorter version of this video. It is in the resources down below. Check it out in the YouTube channel section beneath. This is a longer one for those that have got a bit more time or are more interested in looking at it. We're going to be covering the nature of the dynamic arrays. So we're going to be looking at spilling and the old legacy array formulas. We're going to be looking at implicit intersection and the @ symbol, and we're going to be looking at the 6 new dynamic array functions, which are sort, sort by, filter, unique, sequence, and rand array. And we'll also be looking at 2 new functions that are still in, at this point in time anyway, in preview mode, which is XLOOKUP and XMATCH, and how they will be impacted by dynamic arrays too, now that dynamic arrays are starting to go generally available. They're on Excel on the web, they've been on Insider, and they're slowly rolling out to everyone that's got Office 365. Now, things to note here. They're not going to be on 2016. They're not going to be on 2019. I've had this from the horse's mouth of the program manager who's head of the project for dynamic arrays. If you want DAs, you're going to have to go on the web, or you're going to have to go to Office 365 for the foreseeable future. Okay, this is not death by PowerPoint. Let's come straight out of here and let's just go straight into Excel. Let me explain the past first of all with an example. Consider the table I have in columns A and B. I've got a random list of dates and a random list of sales. What I want to know is, at a given date, what were the maximum sales I had made before or at that date? If I wanted to do this in the old version of Excel, I used to have to use what was known as an array formula because there was no function at one time that would do this, that you could just go and press enter. So you used to invent one. And the way you do it was you go equals max, open brackets, if, open brackets. And notice I always type all my functions in lowercase. This is something I've done for 30 years because I know that if there's a problem with the formula, I can go back into the formula. If it's not capitalized, I know I've typoed it. That's all I'm doing here. If I then click on this range and say that's got to be less than or equal to this date here, then I want it to take the actual max of these sales here. Close brackets, close brackets. Now, because I'm actually doing a whole range, the if statement only looks at one cell at a time. It's saying, well, hang on a minute, I can't do if A2 is less than or equal to E2, and if A3 equals less than or equal to E2, and if A4 is less than or equal to E2. It's got to keep an array, a kind of a list of all of these in there, and then sort them out and decide of those that then qualified, take the relevant B2 to B20 and work out the maximum. And the way you had to do that was you had to press Control-Shift-Enter to put these braces in, and then you get, lo and behold, the value 946, which is indeed the value when it occurs. And just if I use index match to get this out here, so if I go index, because these dates are unsorted here, and I say, okay, I want it to match this particular value in this range. If you don't know index match, we have other videos on that. That's we're going to go here. Oops, put comma 0 in. Maybe I should watch it myself. And we will have the 24th of August 19, which you can see is here. Now, what's happened as dynamic arrays have rolled out is that Microsoft has realized that this Control-Shift-Enter method of actually typing in a formula is causing problems. It was actually making things less efficient, it was causing memory issues, and so on. So in order to get around this, they wanted to get away from the braces. They wanted to be able to do it without the braces. So it used to be impossible. If I just click on this and press enter, what would happen is you get an error message. Not anymore. And that's because of this new dynamic array calculation engine. So if you've got Office 365 and it's slowly rolling out so that you have that, or you're in Insider Fast or you're on Excel on the web, you will now see that's working. You see, Microsoft was so preoccupied with this in the past, they actually even had a function to deal with things like this. They had the max ifs function, you may recall, came out a few years back for Excel 2013, which would actually do this. So this was how they would do it in the past. Now, okay, you can still do it that way, but you can do it this way as well. The difference between the two is, whilst they're of pretty much equal length, there's nothing to stop me coming up with brand new functions like I want the third largest, which they're not going to do a third largest ifs function, are they? So you could just use the large function with if, and then you could do the same thing again, and you wouldn't need to do Control Shift Enter. That's the whole point. Dynamic arrays are trying to make the whole braces thing disappear. Now, why are they trying to make the braces thing disappear? Let me explain. If I were actually trying to have a range, so if I wanted to, let's say I wanted to transpose these 4 values here, you could actually transpose them by highlighting 4 values, and you go in here, equal transpose, old Excel function here, and instead of them going down a column, they'll go across a row, and what you used to have to do in hit as well is go Control Shift Enter, and it will put them in. Now, that's all well and good, but what happens if I want to insert a column here? Only Chuck Norris can change part of an array, and that was the issue here, that it made it inflexible. Similarly, if I just try to delete 2 of them, you can't change part of an array again. It's an all or nothing thing, and often it was actually difficult to find where the array started and ended. This could cause problems as well, like, where does it start? Where does it end? And so what you'd have to do is you go to F5 or Command G on the MacBook, click on Special, and you go hunting in here for the current array and click OK, and it would show you the whole range. And most people don't even know that. So this was one of the things in here that Microsoft was trying to make sure that doing more powerful functions in Excel became easier using less memory without them becoming restrictive, and just making formulas much, much simpler, as I'll show you as we go through. So that's the general idea. Let's now go and have a look at the example workbook I have for you. So if I come out of this, I have behind this my SP Dynamic Arrays example updated starter file. So we've updated this video since I first put it up. I'll explain why a bit later on. In here, there are 2 versions of the file that you've got as a resource for this video. There's a starter file and there's the finished file, so you can just follow along at home by looking at the final examples, or you can play along and do the same things I'm going to show you here. So one of the first cool things to do with dynamic arrays is watch one really cool behavior to begin with, which is actually to take my table here. I've got my shape color slides, really important data table here, I'm sure you'll agree, and actually go through and say, all right, I want to replicate that down here. And you just go equals and take this, no Control Shift Enter, just press Enter. What? Do you see? It's actually put it into this block. Put it in there. Now, it's not formatted it. This is one of the issues at the moment with it, that it's not formatting per se, but I'm sure that will come in time. But who cares? We can format that ourselves. We've actually got something here which is dynamic. It's a range that we can actually move, and it's versatile, and it shows it's this whole range by putting this little blue box around it, so you can see that it is all part of the same range. Now, one of the cool things here is if you click on this cell, you'll see it's actually got the formula F12 to H27. All through these example files, I have just highlighted the actual cell where I put the formula in, because obviously it expands, it spills. This is what we call it. This is known as spilling a range. All of these here, do you see that the actual formula bar, the formula's gone grey? Feeling a bit off colour today, obviously, but it's gone grey because this is not where the source formula is. Notice I don't need to start putting absolute references in, no dollar signs required here. I can just put it in like this, and it's all working quite admirably. I can go through, I've got my dynamic array result, my colour, my slides. It's looking quite simple for me here, and I can actually type things in. So it's not stopping me from typing in here. So if I type in, I don't know, let's say blockage, and press enter, oh, what's happened here? Well, you can see here this error. I'm leaving the arrow to the comments stuck as they are because of the fact that it makes life a little bit easier for you to follow along afterwards. It's gone hash spill, which is a new error that's come out. So there's 2 new error messages that have come out. One is hash spill to say, look, you've got a problem here. You haven't got enough cells to actually spill into, or there's something in here already, but there's something causing an actual issue. So if I click on this, I've got a blockage, and I'm going, oh, okay, well, what do I do now? So I've got this actual spill error in here, and I'm thinking, well, I need to sort it out. So if I remove the blockage, it puts it back in. All good. Let's extend the idea further now with a second example on this page. Here's a table. So a table is just a list again where you then go and click on insert and you go down to table and create a table. This is one of the ways of getting a range to extend because I can put more into this table. I can add rows and I can add columns and it will automatically extend. Well, it will do the same thing with a dynamic array as well. If I just go here equals and I just highlight this whole table and press enter, lo and behold, I have the exact same table here, and it says, okay, I've called the table basic array example, and it's put this hash all in. Now, the all is the symbol that gets used normally just to say that you've brought in the entire table, and hash means complete. It's the whole thing here. Look, it's my definition of it, but it means complete. But that hash symbol is quite important because now that I've got this as an array, this array will actually change. So if I put another one in here, it will automatically update. If I go here and I actually refer to another spilled range, if I just do that, that's not very exciting. But if I go instead equals and I select this whole range like this, do you see it puts this hash symbol after it? And this is the new operator that says the whole spilled range starting in the top left hand corner of cell L57. That's what's going on here. And if I press enter, it puts that in. Isn't that cool? Now, the reason this is useful is I can create drop-down boxes. So for data validation, I might decide I want an actual data validation list. So let's go back in here, and I know I've got duplicates in here, but let's just bear with me for the idea. If I go here, let's just go equals and click on that, I get this spilled range, shape, triangle, whatever. If I go here and go equals to this, it gives me that cell and the hash symbol, L33 hash. Now, I'm going to copy that, right? And then I'll get rid of this. I'm going to put data validation in here instead. So I'll just go here, and I've even put it in a different cell. So let's just make it look like a cell. We'll make it a blue, and we'll give it a yellow font and a border so we know it's an input. And I'll go to the data tab, and I'll go to data validation, and click on data validation here, keyboard shortcut Alt-DL. This brings up this particular dialog box here. I'll go to list and I'll type in that actual reference equals L33 hash and click OK. I get the whole range. Now, why that's useful is if I start reducing this, let's say I delete this. Okay, notice I've made an error here with the spill, so it's got the zeros. Don't worry about that. Do you see there's only 5 elements in here? It's reduced the range. Now, this has always been a problem where people have used dynamic range names and offset and count A and goodness knows what else to do this. We can now do this quite simply just using the hash symbol and referencing that in the actual data validation list. Now, be careful, the other ways of trying to do that won't work. That does seem to be a way of getting around the calculation engine's foibles, but it's a great way of being able to update a list in a dynamic list environment so that you've got in data validation, you can actually extend or retract, or contract, should I say, the actual list of data. Pretty cool, I think. Now, there are strengths and weaknesses with this. Sometimes you'll want to use a table because a table can do the same sort of thing. Let me just be clear here. In another video, we've shown that any chart data should actually be put into a table because when you extend the table, the chart will automatically update as long as you've referenced the entire chart. So I've got here, I've got January to June and some sales, and I've got a table. Chart, and then here I've got a dynamic array where I've just used chart data table all and then reference this to that data instead. There are some advantages still to the in inverted commas conventional way of doing things. If I actually put July in here, or put we'll even try and type July properly and put 70 in, you see this table automatically updates. Now the dynamic array has also updated to 70, but the chart does not update. So there are places where tables may still be more useful, and this is the whole thing with all features and functions in Excel. Nothing's perfect for every situation. You just need to know which ones to use when and why, and just move it accordingly. And that's just what I wanted to show you here. Now, before I go on too far and start introducing all the functions that I've shown the spill and the spill hash spill error, there's one other thing I want to actually explain is what does this mean for the legacy array formula. So if you are looking at this and thinking, Liam, I know what an array formula is. I know how this is all working out, and I've actually got models that are already using array formulae in them. How do I make sure that it's going to keep working? Well, don't worry. Microsoft can't get rid of anything. So many people forget that before VBA there was a previous programming language. It's still there. Many people forget that apparently they're going to deprecate the concatenate function because they brought in concat and text join functions. Guess what? Concatenate, it's still there. They can't get rid of anything because they'll be scared to death if something gets removed or they change something. So, for instance, I am sure in hindsight with the match, the default number of 0, that it's got to be in ascending order and then find the largest value less than or equal to what you're looking for is not what most people want, but they didn't realize. But because it took them so long, they can't change it, and these are all for the same reasons. If they change anything, it could have adverse effects on existing spreadsheets that could cause problems, which quite frankly, people might go back and think, well, we're going to have to sue Microsoft now. So they're not going to do it, so it's one of these things here that it's going to stick. So all these legacy ones will still stick around. So what they've done is they've brought in this thing that was originally, if you were watching my early videos in late September last year when dynamic arrays were first introduced, there was a new function came out called single. And the single function would actually say, okay, this is to make it work like the old version. And the old version has been known as the array formula type. You'll see Microsoft talk about this as what's called implicit intersection. What the heck does that mean? Well, let me show you with an idea here. If I were to go here, and I've got this table of points here. Actually, let's put it here so it's closer to see. If I went equals, actually, let's highlight this range. And then I went equals, highlighted this range, and then used the old way, Control-Shift-Enter. It actually puts all the numbers in there. Now, that's all well and good. That's what you'd expect, and it will be protected that you can't insert any rows there. Now, if I were to just go here, equals, and I actually went in here and I went to all this like that, I went Control-Shift-Enter, it puts 717 because I've only put one cell in, so it gives me the top left-hand corner of the range, which is going to be 717. So if this range were in fact this bit here, it would still give me the 717 because it's the top left-hand corner. It shows it can't display the rest. If instead, though, I'd actually just put equals H13 to H27 in like that, it will go in like this. Great, that's spilling because there's nothing to block it. If I went back to what I did before here, well, maybe I only want certain values in here. Well, the way that you would actually get around that is I'd just go in here, equals, and put the @ symbol in to say I want this to operate as it did previously, and then click on this range like this. It won't spill it. It will show me the actual 978 because that is the corresponding value for this row. It's when this range intersects with this row, the implicit intersection. And similarly, if I copy this here and I just take it like that, Control C, and put it in here, again, it will put it in. Now, if you have existing models that were built using Excel before dynamic arrays were propagated through them, you may find when you open them up with an Excel version that supports dynamic arrays, this @ symbol all over the place. Don't fret. This just means I'm calculating this the old way and should just be ignored, and don't think about taking it out, because the fact is it may actually behave in a different way if you do. So leave it in there, but read the formula as you read it before without the @ symbol. It just means behave in the old legacy version of Excel. That's what we mean here. And don't worry if you then send this file to somebody else who's not got a dynamic array version in, they won't see that @ symbol. In the older versions of Excel, it gets removed again. So you can see they've done a bit of work here. This is one of the reasons why it's taken so long for dynamic arrays to become generally available, is they've actually had to go through and they've had to go and say, okay, we've got to make sure this is backwards compatible, etc., etc. So this just gives us an idea. So that's the @ operator. It was a single function before, and the reason I mentioned the single function, because if you've not heard about it, you think, Liam, why are you telling me that? Is because if it does appear in a new version, so if you actually type this in deliberately, so there is a distinction here. If I have an old version of Excel and I've used the offset function in there, when I open it up in the new dynamic arrays one, it may have an @ symbol in there because it's saying it's got to use it the new way, because an offset could inadvertently spill depending on how you use it. If, however, in the dynamic array version I typed in an offset function and put the @ symbol in, when I take it back to the older version, most of the time it will actually put the @ symbol still in there, but it doesn't know what it is. So then you get this _XL function in braces issues saying this, we recognize this is a newer function that's not in this version of Excel, but it doesn't do XL function dot @ symbol, it does XL function dot, and this is where the weird bit, single. So they've not gone back and coded up the backwards compatibility, and I imagine that's because it's a big job. So that's just stayed as it is. Just an aside. Okay, let's move on. So we move into the actual dynamic array functions themselves, and we'll start with the concept of the sort function in Excel. So this does exactly what it says on the tin. It sorts. So let's say I have here various people who have actually taken a test, and this is the points they scored. So can I order these points in the correct order? So well, yeah, I just go in here and I type in equals sort, open brackets. And as soon as I do that, it gives me here the screen tip up here of the array, the sort index, the sort order, and whether to do it by column or by row. So most of the time you'll be sorting things, if you've got it in columnar format, by column. If you've got it going across a row, obviously you'll use a row. What we have got is we have the range, which index is the one that you want to sort by, and do you want it to be ascending or descending, and that's basically it. So the sort array here, let's just do it on points. So I'm going to take these points here. Keep it nice and simple, and let's just do that. Let's not bother with the others, because it said it put them in square brackets saying that if you don't put them in, it doesn't need them, they're optional. So let's see what happens. It puts them into ascending order. So if I wanted it to go to descending order, I just go comma, the sort index, well, it's only one, there's only one column there, it's H13 to H27. The sort order, though, if I wanted to make it descending, I can either double click on there, tab it, or just press enter, and I've got it the other way around. See, I've seen user-defined functions trying to sort that out. That's how easy that is. Sort is not that difficult. And okay, that's where it wanted the sort descending points in there, but yeah, I wanted to show you anyway. I want the full table instead. That's pretty simple as well. I just go okay equals sort, open brackets. Let's go get the whole table. Let's go back up here and take my table. And then I want it to be sorted on the points one, which is the third column. So I'll put that in. And then the order, I'm going to have it in descending order. So I'll just type in -1 and we'll go close brackets, press enter. There it is. I've seen chapters of Excel self-help books out there show you how to do this using VBA, dynamic arrays, rank function and index match and goodness knows what else. And we've done it in 2 seconds using dynamic arrays and the sort function. Pretty cool. Now, One of the things you may have noticed in here, we've got Blake and Ivana. So Blake 7 and Ivana Tinkle. Well, so I always use Ivana Tinkle because I write articles in various magazines and I got told off for using poor old Ivana in one. So got into trouble with that one, so I always use it. If you've got duplicates, you might actually want to have a kind of like a tiebreaker. To do that, you'll need to actually sort again, and this is where we can actually go and say, okay, we can sort in a different way. So to actually sort that, I know it's actually working as it stands at the moment. Let me just take this formula again and put it down here. So if I take it that way, I can just go 2-stage. So I've just cheated to put that in again. Now, as it stands, I want Blake above Ivana because 7 comes before Tinkle in the alphabet, because S is before T. But I want to be able to actually change this order. So I'm going to actually sort on 2 columns here. So I'm going to say, okay, I'm going to go, I want it to go as follows. First of all, I want it to go, so we put this in braces. And this time I just type this in. This is not Control-Shift-Enter. I want it to go on 2 different columns. So I'm going to have it first of all on column 3. And then after that, I'm going to have it on column 2. Now you have to put the semicolon in there because it's a column. You're separating between. If it was rows, you'd use a comma. So you go there and put that, and then ascending or descending, again we'll put these in for actual. I want the first one to be descending, so it's -1, and then for the second one I want it to be ascending, and put that in and close brackets, and we then get this thing where we still get Ivana going above, going below Blake 7 here, but now it's forced. In this one, it was coincidentally, and the reason why Blake 7 was above Ivana Tinkle in this is because of the fact if you went back to this list here, Blake appeared above Ivana in here, and it just goes down the actual list systematically. But if you wanted to force it so that you'd actually got it in there, that's how you would do it. Pretty simple, really. Now, sometimes the old version of Excel and the new version collide. If I only wanted to show the top 3 points, for instance, I could actually get this in a different way. You could use the large function with dynamic arrays and do it that way, and then it would just spill to 3 rows, and you could actually have it that you could make it the top 4, the top 5, and so on, and it would automatically extend. But if you wanted to just a simple fix, another way of doing it very, very simply, a little cheat, is to actually highlight the range you know it's going to spill into these cells here, and you go instead equals sort, open brackets, back up to this range here, highlight this whole table, and yes, I've realised I've just put an asterisk in there, that should be a comma, you moppet. Comma, I want it to be sorted on the 3rd column in descending order. Now, because I've done Control-Shift-Enter on that 3x3, it's restricted to that range. So if I go Control-Shift-Enter, bang. If I go in now and have a look what's happened, you'll see if I go back down here, it's only restricted it to those. Now, the disadvantage here is, again, I can't insert rows or columns, things like this, but it's one of those things that can be a useful way of getting your top 3 or your top 5 if you don't want your 3 or your 5 to be a variable. If you want them to be a variable, then use the large function to get your highest 3, use the small function to get the bottom 3, and then let it spill. You see, this is the whole point. I'm showing you the new functions that come out with dynamic arrays, but you can still use the old ones with them and use the spill technique just by showing the whole range. It's pretty cool. Now, so some functions will not spill. Some won't, because some aggregates everything and forces it into one number. That's known as coercing. So if you use a sum there, that's just not going to work, and I'll show you why you should avoid the sum function a little bit later on. But on the whole, most of them will work quite happily with this. So that's the first function. That is sort. Next up is the SORTBY function. Now this is slightly or subtly different to the sort function. With sort, the thing you want to actually sort is in the output. With sort by, it doesn't have to be. We can do exactly the same formula, but it's something that it doesn't need to be included. And I'm going to go a little bit off the actual example that's in the final version here to demonstrate that. It's really simple. It's pretty much the same idea as sort, but you don't need to show it. So if I type in here equals sort, I can have sort come up, but if I type the B in as well, I get sort by. So in this particular instance, I'm only going to want the first two columns to come back. So I'm only going to highlight these two, but I want to sort it on the points. So now, for this next argument, it says, what are we going to sort it by? So we're going to sort it by this one, which is not going to be included. And then we're going to have it in descending order. And if I press enter, there you go. I have the actual data coming out, it's just not got the points in there. And that can be useful. So sort by, that's simple. Let's move on. Next one up is the filter function. So the obvious way here is if I were to actually highlight this data here and go to the data tab and click on filter, I can actually filter up here. And so if I were to filter this on, let's say, I don't know, triangle, it highlights this data like that. Now, that's the way of doing it using a filter. How about if I wanted to do it formulaically? So here I've created data validation where I've actually put in a list of different shapes. Notice, by the way, pentagon is not in there. So I've not got pentagon in, which can be something that can actually happen. But filter can actually be done formulaically. So you say, what is it you want to filter? So I'm going to go equals filter. And even better, if I actually type this correctly, oh, if I had a brain, it'd be dangerous one time. So if I go filter rather than filter XML, that's an old function in Excel. We will get this working eventually. Filter in here, I want the array. The array in here is going to be all of this that I want to bring back. Then I actually have the stipulation, my criterion. So my criterion here is going to be that this column here, G13 to G27, has to equal that. Again, I don't need to put any dollar signs in. And then the final argument here is what to do if it comes back empty. You can just put nothing there, it'll just return 0, or you can just go in here, not located. Close bracket, press enter, and there we go. There's all the shapes up there, which are triangles. If I change this to squares, I've got 3 squares, and if I change it to pentagon, not located. How cool is that? Now, we can actually do this with multiple criteria. So we can look at both and or. So just to recap here, and everything has to be true. So if today is Saturday, which it is as I record this video at the moment, and I am in Melbourne, which I am, and I am the best looking guy you have ever seen, all 3 of those criteria have to be true for and to be true. This is false though, because not everywhere in the world will it be Saturday at the moment. Got a problem with that? Oh well, I have the perfect face for radio. Let me carry on. So with and here, I've got multiple criteria. Now the trouble with and is if you use and on an array, it tends to work like or because of how the mechanics of it works through. So you can't really use the and function. What you actually have to do is you have to multiply conditions together like you do with some product. You've seen that example before. So what you do is you put something in brackets and you put the criterion in like we have here with this particular column equals pentagon at this moment in time, and it will either go false or true accordingly. And if you multiply this by another number or another calculation, it will act as 1 or 0. 1 if it's true and 0 if it's false. And that's how we do ands. We multiply conditions together after putting them in brackets, because otherwise multiplication often takes precedence to equality. So we have to put them in brackets so that it actually determines the condition first and then multiplies them together. So true times 5 is 5, true times false is 0 because we've got 1 and a 0 in there, false times 19 is 0. This is how it works, and that's the general idea. So in here, I want my shape to be a triangle and the colour to be red. That's what I've got here. So it works similar to before. I will go, okay, equals filter, and this time It's not letting me do the tab thing in here this time. It's okay. So I've noticed this twice. So a little glitch in here I'm noticing, and I'm recording this live. Normally what happens is after you actually type filter and you press the tab function, it will capitalize the actual function here. For some reason that's not working with this one, but don't worry, it still works. It's just an interesting little bug I've spotted there in this particular video, because I thought the first time I just messed it up, but I've done it twice now. Not a big problem. Take my actual range here, comma, and then I'm going to do my conditions. So remember, you have to put them in brackets. So the first one, my actual shape, has to equal triangle. So that's going to go, if we go through here, it's going to go true, false, false, true, false, false, etc. So wherever there's a true, it's going to act like a 1, and wherever it's a false, it's going to act like a 0. And we then multiply that by the second condition, which is these here, and then, not a closed bracket, we go equals what it needs to be, red, close brackets, and that's that. Now, something else we can do as well, we can actually put not located in there. Now I can just type not located like I did before, but this time I want to put something underneath each of the 4 columns. If you notice back up here, it just put not located under the first one because that was how I'd put not located. If you want descriptions to go across all 4, what you have to do is you have to put it in braces, and because we're going across a row, we separate it by a comma. So I might decide I want a dash for the first field. I want it to say none for the second one. Then I'm going to have it be, oops, can't even type under pressure, comma, n. Yeah, I want to forever keep pressing that full stop, don't I? And then close braces, and then because it's the end of the formula, close brackets, press enter. There you go. It's put it in. So I've got red triangles everywhere. If I decide to go for a amber triangle, I get hash none NA NA. How cool is that? Pretty simple, don't you think? Now, same idea this time with OR. So OR, only one has to be true. Let me be clear here. One or more has to be true. It doesn't have to be an exclusive OR here. So we're going to say one. One or more is true. So again, we've got rectangle and red. So same idea. And this time I'm not going to press the tab button to keep getting the error message. Let's go filter. We'll highlight this range. Comma, first condition, open brackets, is triangle equals this thing here. Now, this time we don't put a times in. We want it to be an OR condition. Now, when you use mathematical operators, then trues and falses become 1s and 0s. So if I do plus, and I do this other one here, and I go and look at this one and do the same thing there, equals red, close bracket, we'll either get true plus false, false plus true, or false plus false. Now when you add them up like this, I will therefore get 1 plus 1 is 2, 1 plus 0 is 1, 0 plus 1 is 1, or 0. Now all numbers in here actually act as true or false. 0 is the only number that acts like false, and everything acts like true. And filter is just looking for true or false as a condition here. So the fact that this could possibly add up to 2 is irrelevant. It won't double count it. It will just mean it will include the record. And then again, I'll put in my list of things that I want. And let's see if I can actually use a / rather than a full stop this time. So we'll go in here. That's the first one. Remember, it's a comma because we're going across a row. Then we'll go none, comma. Then we'll go n /a. Yay! I managed to use a /. And then we'll do the same thing again if I can. Look at that, on a roll this time. I should try for the baguette later. Close the braces, close the brackets, press enter. There it is. I now have an OR condition. So whenever it's red or it's a rectangle. So that one it's red. This one it's a rectangle. This one it's red. This one's a rectangle. That's a rectangle. That's red. That's a rectangle. See? How cool is that? So that's the next one in here. That is filter. Let's continue. Now comes one of my favorite ones here, which just makes me laugh. I'm sorry, I'm already smiling already. We come to the unique function. Now, why this makes me laugh is because unique is not unique. There are two meanings of unique, and Microsoft did some research on this apparently, and they realized that Excel and database people use this differently. So in here I've created a list of, possibly if you're an Excel person, you might want to have a list of all the different salespeople. So I've got Alice, Barbara, Charlie, Dion, Echo, etc. But you'll see that a lot of these appear more than once. I just want an exclusive list of all the people with no duplicates. That's one meaning of unique. Another one can be, though, which records occur once and only once, and that's a second meaning of the word unique. And unfortunately, they've used the unique function to deal with both. I don't know why they didn't bother just having two different functions, but in their infinite wisdom, they decided it was all going to be under the same one. So I would have called this function not unique, but there you go, that's another story. To show you its default setting, first of all, it's pretty straightforward here. If I go in here, I can just go equals unique. Notice I can tab it again now, don't get the error message. Highlight all this going down here. And I get the list, north, east, south and west. And they come in that order. It's not alphabetical, it's come in the order that it's found them. So north was the first one it found, then it found an east, then it found a south, and so on. If you want to sort them, well, guess what you do? You just type a sort around it. And you put this in. Now, I have seen people write hideous user-defined functions to create that, and we've just created this in seconds. How cool is that? Now, it can get even more complicated than that. How about instead, I want to see all the combinations of section and manager. So I want to know what combinations are possible and have that in a different list down here. It's just the same idea again. I just go here, equals unique. And I just highlight the two columns and it will look for things where they are distinct, for want of a better word. There you go. They're the only combinations that feature in there. It's not that difficult. Now let's carry on with another example here. We'll go down to unique examples and show you this single occurrences only. We can compare and contrast. So for the salesperson here, I'm going to look at all the different salespeople, Alice, Barbara, Charlie, etc., and see which ones have only got one responsibility. They only appear on one row, so it's just one occurrence. So again, we start off with typing in unique, and then we will highlight the field, G56 to G84, but this time we'll take more of a look at the other arguments. Now the default for the second argument is false. It's going to return unique rows only. You can return unique columns, so can go to false here, or we can just type in 0 is another way of doing it. And then we've also got here the option of returning items that appear exactly once, or return every distinct item. Again, the default argument here is false, but this time we want it to be a 1. So for true, so press that in. Here are the 4 people, Echo, Jack, Lindsay and Opera, in the order that they actually appear in the list. So we could sort it if we wanted to, of those that occur once and only once. Now, for the other one, for the managers, we're just going to do it instead of using this one. We can just sort them if we wanted to and see the managers just to compare and contrast. You can actually still use other things in here. Sort unique. How about we go take the manager? Oops, let's only go as far as we need to. Close brackets, and that shows you the other way of actually pulling the data in as well. So we've got here all the distinct managers, because none of them actually have one responsibility, so it would have been 0 if we picked that up. So I'm showing both those. So these managers ought to know that, well, hang on, maybe Winnie should look after Echo and try and get do more work. Xander can look after Jack, etc., etc. You get the idea. It doesn't have to be exactly that, just something that you could actually put in and sort out. Right. Here's a comprehensive example to finish off with, just to show you just how convoluted it can all get. I've got here, let's have the section and the manager, and it's going to be nice and simple to begin with here. We will go and just use our sort unique again. And we're going to have the section and the manager. So I'll take this one, close brackets, and if I've done that, I can just copy that across, can't I? There you go. weird, copies across and it's not at the same length. So I've got section manager and I have actually got my summary. Now what I've done in here is for my section and my manager, I've used that to populate my drop down box. Remember from before? So I've got in here, I've got the different ones, audio, video, bedding, computers, etc. And if I go Alt-DL is the keyboard shortcut, you will see that I have used the L94 hash idea to populate that list. And similarly in here, I've got Winnie, Xander, Yvonne and Zach. So if I put in here Alberto, you see Alberto goes in there and we will now see this list extends to 5 should we want it to. Now I'm not going to keep Alberto in there, but you get the idea of what's going on. So now, maybe what I want to do is I want to actually have a list where I can use and or with this. So it's getting quite comprehensive. We've got quite a little list going in here. So are you ready for this? This is probably the one of the biggest monster formula we're actually going to try and do in this entire session. So it's going to start again with sort and unique like we've done before. Sort, unique. But then we're also just going to have another one. Let's filter it as well. That one I can't tab. So I'm going to filter for the table. I'm going to actually use the row headers in here to be consistent with the actual workbook that you've got for download, although you don't need to put that in. And then what are we going to include? Well, we're going to have an if statement here. We're going to choose between or and because we've got a drop down box here. So we'll go, okay, if this happens to be equal to or, then we'll need to put our conditions and add them together. So that's going to be this column here, making sure I actually bring in the section and put this in like that. Remember, you've got to have it in brackets so it evaluates the condition first of all. H93 to H122 equals computers, which is M105, and then it's plus because we're using or, and then we'll take the second condition, so I'll take all of these here, managers, and I must make sure that actually goes to 93. You see, old habits die hard, don't include the headers, but I'll put it in, equals, and that equals Winnie, close brackets. So that's if it's an or. If it's not, what I'm going to do now is I'm just going to copy all this, because I can't be bothered to type all that out a second time, comma, paste, and then I'll change it, because if it's not or, it's and, so that will have to be at times, and then what we'll do is we will actually need a second close bracket to finish off the if statement. Then now we're back in here, we're back in the filter. We want to say, well, what happens if it's not found? Well, we want to actually populate the store, the salesperson section and manager with not found. So it's going across a row, so that means we're going to be separating it by commas. So we'll do n/a again, and then we'll do perhaps in blanks, and then close braces at the end. So that gets me to here. Then we'll close the bracket to finish off the filter. Close the bracket again to finish off the unique. Now for the sort, we want to sort it on all 4 columns. So the columns, remember, we need to identify them. I'll get split not by a comma, but by a semicolon. So again, in braces, I'm actually going to put in here columns 1, 2, 3, and 4, because that's the order I want to sort them in. And then what I'm going to do is I'm going to actually say the order whether it's ascending or descending. So it's going to be 1 semicolon 1 semicolon 1 semicolon 1. Didn't need to do that, but I'm just trying to make it very comprehensive, and close brackets at the end, and hopefully there you go. We have one comprehensive list where we can choose the different things. So if I move this from computers to audio video, and from Winnie to Xander, and from or to and, how cool is that? You gotta say, that's pretty comprehensive, and that's used a lot of the functions we've had so far: sort, unique, and filter, plus or and in a way. Okay, so we've covered the @ symbol, we've covered sort, we've covered sort by, filter, and now unique. The penultimate function now is sequence, which again doesn't necessarily look like it's that exciting to begin with, but it's got more use than you might think. The best thing is, let me just actually put something in and show you. Sequence generates a sequence, and it doesn't look like much to begin with. If I go sequence in here, and then I click on this, comma that, comma that, comma that, Thank you for the explanation, Liam. I get that. So what does that mean? Well, that means here, what I've got is I've got a specified a grid of 3 rows by 4 columns, starting at 5 and going up in increments of 6. So it starts at 5, it's got 4 columns and 3 rows, and it goes up in 6, 5, 11, 17, 23, then to 29, and so on. That's fascinatingly. Well, yes, even more fascinating. How about if I get a little bit more exciting here and do something like, let's count up the Roman numerals. Here you go, equals Roman, open brackets, sequence, and then I'm going to have it 10 rows by 10 columns, starting by 1 and going up in increments of 1. So I can go close brackets, and we have this wonderful thing here. Press enter. There you go. All the numbers from 1 to 100 in Roman numerals. How did you ever live without knowing that? Look, sequence can just be as simple as this. You can just go sequence and do 5. And what that does is it generates the numbers 1, 2, 3, 4, 5 going down. If you make it 1, 5, what it does is it's the same as transposing. It makes it actually go up. And the reason you don't see all the numbers here is because I've got some hidden columns. Oops. But that would have been the numbers 1, 2, 3, 4, 5. Let's move that down here instead. Put it here. Sequence 1, 5. Bang. Done. So that's how you can make it go one way or the other. This is fascinating, Liam. I'm not seeing too much use for this so far. What the heck is this all about? Well, let's have a look at this thing here. So in this embedded illustration, this shows you how sequence is more useful than you might first think. Not only can it be used to aggregate monthly interest payments in one cell, rather than having to calculate them explicitly, it's also used to generate the row and column header numbers, and we can do it without Control-Shift-Enter, so it's pretty nice and easy. So let's have the numbers. So I'm going to have a term of 5 years going through here, so I can actually work it out what the numbers 1 to 12 going across. So that's because I want to have this for the months of the year. So I'm going to go here, equals sequence 1, because we use the transpose function, and I'm going to have, I've already invented this earlier, months in year is defined as 12. So if I do that, close brackets, I get the numbers 1 to 12 going across here. What I'm going to do for this one is I'm going to have the borrowing term of 5 years. So I'll go here, equals sequence, and it's going to be this number here, borrowing term. And I've actually got that in because what I've done is I've got some calculations in here for the actual formula. Look at that, nicely calculated it all. I've accidentally knocked out the first calculation here, but I've gone in here and I've used the IPMT function in Excel, the interest payment, to actually work out what the rates are. Now, I don't want to go through a rather specific comprehensive example in too much detail here. You can see the numbers are coming up here, but look at this. I can actually do it using just the sequence function as well. Now, I invite you to play with this in your own time because I am conscious this is a little bit more involved than some of the others and is only really going to be of interest to those looking to calculate interest payments in here. But you can see the proofs in the pudding that it does generate the same numbers. This is the conventional way of doing it. If I make it 10 instead, you can see it mirrors it. So it's quite nice and easy as an embedded sequence example. So pretty powerful stuff. Final function for the dynamic arrays, it joins rand and rand between as 2 random number generators built into Excel. Rand, you may recall, actually generates a number greater than or equal to 0 but strictly less than 1. Could be of many decimal places, so 0.7596448 could be one such example. Whereas what rand between does is it generates an integer, that is a whole number, between 2 given numbers a and b, where a has to be less than or equal to b. What RANDARRAY does is allow you to do both of those things and specify the range you want to actually get the output over. So it's pretty easy in its simplest shape or form. It doesn't actually take that much in terms of rocket science to put together. You just go, okay, click on here, equals RANDARRAY, and we'll just say it's 3 rows and 4 columns. Notice all the arguments are optional. And it generates random numbers between 0 and 1 in this particular instance, because that's the default values over 3 rows and 4 columns. We can make it look like rand between those, as said. So if we actually start using all the arguments of RANDARRAY, we can start choosing different options. So I can go RANDARRAY. I want it to be 5 rows. I want it to be 8 columns, starting at 1, finishing at 10, and I want it to be an integer rather than decimal. So we can go through like this and go like that. And there you go. We get a random set of numbers between 1 and 10, whole numbers, over 5 rows and 8 columns. And I can change all these things to different things. So I can go in here and make that false. I get other ones here. So nice and easy. Well, let's finish RANDARRAY with a stupid example here. Let's say I'm a school teacher and here are my children in my class and some of the projects I want them to do, and I want to assign them a presentation on a random basis and which child goes first. So the way to do this is to use SORTBY and RANDARRAY in conjunction. So to generate the child, I'll use SORTBY, open brackets, and what I'm going to sort by, I'm going to specify I want to sort these children here, and I'm going to do RANDARRAY, open brackets, and I'm going to have to say how many children there are, so I'll use the count A function. So count won't work because count only counts numbers. Count A counts the number effectively of non-blank cells. So if I do that whole thing here, it knows how many kids there are and will therefore generate it on a random basis. If I press enter, I get this list. That's going to be my list of children here, and I can do the same thing for the second argument here. So equals sort by, open brackets, let's pick up my topics, comma, RANDARRAY, and then it's going to be count A again. So we use all sorts of Excel functions to put this together. Close bracket, close bracket, close bracket, enter. And I only need to do it on 1, so notice I've done F79 to J88, that's why it's caused that to extend. So I'll just make that F88, and I need to make that not F79 as well. If I put it in here, I need to make sure that's F88 as well, then it won't go through. And we'll have this here. That's the danger of playing with merged cells. Okay. Oh, poor Felix seems like he's got a rather interesting one, although Diana seems to have a cushy one in week 3. Anyway, stupid example there just to show you how you could use RANDARRAY to actually get things going through. Right, practical, more advanced uses. Data tables is a good one. Here's a data table example. Again, I'm going back to finance, or keep this reasonably quick here. I've actually got a loan amount of $20,000. I want to borrow over 3 years at the moment, or I can select different ones with an annual rate of 4.5%. This is giving me my actual value as PMT, and I put that function in here. So I hide it in the top left-hand corner. So this is how you create a data table. So then what you would do, this is nothing to do with dynamic arrays. I go in here, and then I go to what if analysis in my actual area here. Go to data table, keyboard shortcut, Alt DT. Now this is in a column, so these are my column inputs. So my column input there is going to be that number. My row input here is going to be the amount I wish to borrow. So if I click on that, 2 values, click OK, I get these values. Now, the great thing about dynamic arrays is I don't need to use these anymore. You see it's put the braces in because it's basically turned it into the old legacy style array. I can avoid that data table by using different values. So I'm going to go here and say, all right, I want to actually populate the 10,000 to 60,000 here. So I'll use the sequence function. Sequence, open brackets. I want it to go horizontally, and I want there to be 6 of them. And then it's going to be going from, well, I want it to go 10, 20, 30, 40, 50, 60. So I can't actually use any things. I'll have to type them in. I want it to be go 10,000 in steps of 10,000. There you go. I get the values 10,000 to 60,000. Now, for the actual year term here, I will just simply go equals sequence 6. There's numbers 1 to 6 in there. And all I've got to do now is put my formula in here, which is going to be a variant of it. So I'm going to use the PMT formula. I want it to be positive, so I have to put a minus sign in front of it. It's one of the things that always cause me issues with that. So it's going to be the loan rate divided by the number of months in the year. So we'll use months in year. And then what we're going to do to make this actually work out is I'm going to say, okay, I'm going to take this one here, this sequence 1 to 6, so that's going to make it spill, multiplied by months in year. So we'll get 12 to 72. And then we're also going to spill it this way, so we'll get it in both dimensions for the, if I go close brackets and press enter, I get exactly the same values without using the old method. So again, I don't want to go into too much detail on this because the fact here is it's really just to show you that it is possible to use data tables with dynamic arrays, and you can play with this in more detail to your heart's content. The other cool one to perhaps show you is pivot tables. So I've got here my various football clubs in the English Football League. I'm not the Premier, but the division below it. I'm a supporter of this, sadly. You'll find out which one in a minute. And here's the month, how many, the month number, the points achieved, and so on. And I want to summarize this in a pivot table. So I could just go and highlight all this, go insert pivot table, and put it in. But if I do that, I actually have to go and refresh. So I want to get my football teams in, and I want them in alphabetical order. So I'll use the good old sort unique again. So sort unique, and then we'll go and get my football clubs. So I'll just go and take all this, close bracket, press enter, and there we go. I have all my football teams. Now I want the months of the year. This time I will use the transpose function just to show you how you can do that. You could have used it with sequence or gone a different way, but I'm going to actually sort by the month number because I want it to go by a particular month number. August is number 1, you may notice. September is number 2. So I'm going to use, because I want it to go horizontally rather than vertically. I'm not using the sequence function here, so I'll use transpose. Transpose, unique, and then I'm going to sort by. Is that enough? So I'm going to take the football data for the month. So I want to sort this one. And then what I want to do is I want to do it by the month number, which is going to be this one here. And then all I've got to do is close the brackets about 20 trillion times. Done. I've actually got the months nailed down. Then the last one is pretty simple. I'm just going to highlight the data. Sum ifs will work fine here. So I'll just use sum ifs, conventional Excel function here. I'm going to have the points achieved. So I'll take that down. There's my points achieved, comma. Then I want it to be, in this particular case, if I scroll back up, I want it to be by the football club, comma. And then we'll just bring that back up again. What's the criterion we're going to use? It's going to be this one, all the way down to Wigan Athletic. So it goes L13 hash, and then we need to do it by the actual football data, the month. So it's going to be this one. And the criterion we're going to use this time is the actual month going across here. Control Shift right arrow, close brackets, press enter, one pivot table. Pretty cool, eh? The beauty of this is all formulas, which means I don't need to go to data, and it means I don't need to go and refresh. It will automatically update. If I put in here, let's say I find out an Aston Villa one here. If I make the actual points for there, you'll see for September it's currently 1, which is what's here. Let's make that 199. It suddenly has 199 in there. You'd have to refresh the pivot table normally. How cool is that? Pivot tables without refreshing. Okay, This has been quite a comprehensive time. We've been going over an hour now, and I thank you for your patience if you've been listening all the time. And I'm sorry about my dull, monotonous voice, although hopefully you're seeing some of the passion in here. Dynamic arrays will be rolling out. It's going generally available. There are still some concerns. Watch out for this. I finish off with this particular one. I've got two calculations, and I made this a bit smaller deliberately. Sorry, I can't make this too much bigger. Do you see I've got the same thing twice, and I get two different results. Here, I get the formula is a hash spill here, and on this one, it's a hash spill there. Why? What happened? It depends which one you do last. So that here is transpose sequence H13. That's it, gone. If I now delete that and I go and put it back in again now, it will remember that it's put it in. But if I knock them both out and I do this one first, the first formula is sequence H27. So I get in here equals sequence, and it was H27 in that one, so it's going to be this one here. And then I put in this one equals sequence. I go 1 comma that one. It spills this way. But if I take that out and then I go here equals sequence and put this one in, now it's that one that spills. Now it should be anything that you do in Excel, you should get consistent results. Now there are places like in pivot tables and others where you can actually find that you don't, if you especially start working with circularities and iterations and other things in there too. So I will admit that it's not the only place this is a problem, but you should be careful. They might think, well, Liam, I don't care about spill errors because they're errors anyway, it doesn't matter. Yeah, but for instance, in depreciation calculations and interest calculations, sometimes people will actually create errors deliberately in order to use an if error statement to actually do something else. Now, if the error doesn't arise as you might think it does, because there's no if spill at the moment, like we've got if NA and other error check functions like that, we may find that your formula may not act as intended. So just watch out. I don't want to end up on a downer here. That's not the point. It's pretty cool what's going on here, and I've been raving on about these for a year. If you read my articles at all on the Some Product website or in any of the accounting press, you'll see I go on and on very positively about them. This is not meant to be negative. Just want to say be careful. Like with every function, they've all got tricks, traps, gotchas in there. Just learn to put these into your repertoire as well. Hopefully, you'll be incentivized and motivated to go through it. Thank you for listening to the full-length version. We do have edited versions of this as well, mentioned in the resources, plus a write-up on our website. As I say, that's the end of it now. I'm going to shut up, and I think it's time to sign off. I think that's the longest video I've ever done there. Hopefully you found it really useful and informative. If you enjoyed it, my name's Liam Bastick. If you didn't, my name's Tim Heng. By all means, please check out our website, someproduct.com, and all the resources down below the video. And we'll have plenty more videos on this channel soon, so keep coming back and checking them out. Otherwise, thanks very much.